Algebra 2 yesterday, and they act like they'd never seen it. And I know y'all first saw this in like pre-algebra. And I know I did it with you last year, but remember we name functions different ways? I can put any letter in front. This just means it is a function, and I'm giving it a specific name. Yes, f of x, g of x, h of x. That confused. Okay. It could, yeah. All right, so this is called function notation. Yes. I guess it could be. All right, but what we do is we're going to talk today about operations with functions, and I feel like we hit on this in Algebra 2, and I can't quite remember. But in other words, whenever I add functions together, so if I wanted to say f of x plus g of x, right, and I could combine the terms that go together, I could also write this as f plus g of x, and that means the same thing. Okay, so just when you see this, you know exactly what it is that that I'm asking you to do. Subtraction, same way. Yes. No, I'm literally just adding or subtracting the functions themselves. We'll do several examples with it, and I'll show you. Yeah. No, 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 no. Say that again. Boy. Okay, that's composition, I think is what you're thinking, and we're going to do that in just a second, yeah. I just wanted to show you, first of all, this notation and what it looked like, because we're kind of introducing a little bit of a new way to write it, by the way, on the right here. All right, now, here. You should not put that finger up. Oh, she did say yeah. What? Yes, yes. All right, so here's what we're going to do. We're going to do these operations, but we have to now consider their domains, okay? And I call this a combined domain. And what a combined domain does, are y'all done with that? Don't unplug my stuff. That? Oh, the bottom. All right, so let's talk about the domains and how we come up with a combined domain, okay? Combined domains are exactly what they sound like. They combine the domain of more than one function, okay? So if anything's left out of one, I have to leave it out of the both of them when I put them together, okay? So things like square roots have to stay positive. I can't have zeros in the denominator. All those things that caused us problems before in our domain, they're still going to cause us problems when we combine it with something else, okay? So if it's left out of one domain, it's left out of the combined domain. Oops. So here's what we're going to do is we do these operations. We are going to look at the domain of the individual functions, and then we're going to put them together, and we're going to look at the domain of them together, and then anything that's left out of them individually or together, we're going to leave it out. So it's going to get a little bit hairy at times, but it's okay. Hairy? You've never heard that before? No, I thought you said hairy. Okay, I will say that it's going to get a little I don't know. I don't know. There you go. A little sticky. All right, ready? Y'all got that? Let's say f of x is, we'll start easy. What is, so I'll define the functions for you first, and then I'm going to ask you some questions about them, okay? So first, what is f times g of x, and what is the combined domain? So I want you to find the product of f and g, and then I want you to tell me what its domain is. Now, before we start, what is the domain of f of x the way it sits now? Everything x can be. Negative infinity to infinity. I don't have to leave anything out. There are no fractions, there are no radicals, there's no asymptotes, there's nothing that's causing me any problems, right? Everything's all good. X squared plus x is just a quadratic. Okay? We're going to do it individually first, and then we're going to put them together. My back is hurting, y'all. I'm sorry. Okay. Huh? You haven't ever done what? We're going to do it together. We're going to go. You didn't know what? Yeah. Okay, so let me say this as you go through this. Let me digress for just a minute. When you're looking at domains, and I'll come back to that one, so leave a little bit of space. When we're talking about domains, there's a couple of things that cause us issues. Two main things, actually, that cause us issues. Thing number one are square roots. Because I can never have a negative under a square root. Right? Because then I'm in imaginary land, and I can't have that. So if I had something like the square root of x plus 1, I could graph that because I know what the parent function looks like, right? It would just be the square root slid which way? Left 1, right? But if I think about it algebraically, x plus 1 has got to stay bigger than or equal to 0, right? Because whatever is under the radical has to be bigger than 0 because I can't go negative. Does that make sense? So then x has got to be greater than or equal to -1 if I solve it. All right, listen, everybody listen. If I told you that f of x was the square root of x plus 1 and I asked you for its domain, I am showing you how to do that algebraically without having to graph it because we're fixing to have to find some algebraically. Okay? I have two scenarios that are causing me troubles in domains that I need to look for as I look at them to tell what their domain is. Scenario number one is a radical. If you have a radical in your function, you need to make sure it never goes negative. Okay? This is how I make sure it never goes negative. I set what's under here bigger than 0, and I solve it. So my domain on this one, if I write x is greater than or equal to -1 in interval notation, what do I get? Give it to me in interval notation. What does x is greater than or equal to -1 look like in interval notation? Keep going to infinity. If I were to graph this, I'm at -1, it looks like this. What's the domain of that function? -1 to infinity. Instead of looking at it graphically, I'm doing it algebraically. Yes.
It's just like whatever you add, the x has to be greater than that.
Yes. Because it's going to the right forever. Parent graph is square root of x. I didn't expect all this. Okay, let me show you another one. Yeah. Okay, let me show you. All right, look. If this is my equation, 3 times the square root of 2x minus 5, okay? And I asked you to find the domain. Okay, you would think so, but not this time because I have to, not graphically. I don't want you to graph it and look at it. I want you to think about this algebraically. There's a radical. If there's a radical, take, and I'll even put something else over here. Okay, it doesn't matter. That's not impacting my domain. I take what's under the radical. What's under the radical? 2x minus 5, and that needs to be positive. Yes? Why? How do I know that? Why does that have to be positive? I can't have a negative under the square root. So what does that look like if it's a, well, now I just solve it for x. So add 5 and divide by, it wouldn't be on your graph because you're only graphing real numbers. Yes, so the domain of this one would be from 5 over 2 to infinity. If there is a radical, if there is a radical, you must set what's under the radical greater than or equal to 0. I'm going to show you some things that happen with some other things, but let's. Did I not teach y'all algebraically in Algebra 2? Okay, then we need to camp here for just a minute. Okay. For domain, yes. For domain, I'm looking for one of two scenarios, and that's all I'm looking for. Scenario number 1, does my equation have a radical in it? If it does, if you answer yes to that, then what you're going to do is take what's under the radical, set it greater than or equal to 0. Okay, so scenario 1 is you have a radical, set what's under the radical greater than or equal to 0 and solve for x. If you plug -1, if you've got the square root of x plus 1, and I plug in -1 for x, it's 0. I just can't have a negative under the radical at once I'm simplifying. Okay. All right. It does not, listen, it does not matter what else is in there. At the end of the day, I see a radical in there. I know that the radical is going to throw my domain from the beginning. Okay, I always start with the negative infinity to infinity domain, and then I look at what I can't have. Okay, so in this case, I'm negative infinity to infinity, but what can't I have? Well, I can't have that be negative. So how do I ensure it's going to be positive or zero? It could be zero. Well, I'm going to take just what's under the radical and I'm going to set it greater than or equal to 0. And I'm going to solve that for x. Add 7. Multiply by 2. You can divide by half, yeah, same thing. So the domain, yeah. Square 0, 0. That's fine. You can have that. It becomes 0. Yeah, 3 times 0, 0. And you can have that. You just can't go negative. Now, this means that this domain is from 14 to infinity. That won't always be good. Unless that sign changes. When might that sign change? Well, what if I had something that was reflected? And so maybe I had f of x equals the square root of negative 2x plus 8. Again, I'm taking what's under the radical. This one is negative. So Madeline said, what happens if, is it always going to be to infinity or not? And I said, well, what happens if I solve this? I've got negative 2x is greater than or equal to negative 8. What happens when you divide an inequality by a negative number? You flip that inequality sign, right? So this is going to be x is less than or equal to. So what is the domain of this function? Always. All right, so, and you can look at this graphically and it will back this up. I promise you this works. This one has been, look at the transformations that have happened. That's right. It's being flipped over the y-axis and it's been shift left along with horizontal shrink. But anyway, the point is that I'm like over here and I'm going this way now because I was reflected over, right? So now my domain makes sense from that. So does it always go to infinity? No, it doesn't always go to infinity, but it always sets up greater than or equal to 0. If you multiply or divide an inequality, that's why I'm right here. Stand by. You scared? I know. You scared me rattling on that door like that. We thought somebody was breaking in. Yeah. Oh, thank you. All right. Yeah, they're there, but as far as domain is concerned, we're not worried about it. They don't impact it. One of two scenarios, you're looking for domain. Square root? Right. Okay. All right. That's scenario number 1. We got 3 scenarios to work through for domains, okay? If you are ever solving an inequality in any situation for whatever reason, if you multiply or divide by a negative number, the inequality sign changes. You can add or subtract all you want, but if I had negative 2x, what in the world, is less than, that's a 2 by the way, less than 15, I don't know, it doesn't matter. I divide by negative 2, that sign's got to flip. Any time you multiply or divide by a negative number, it flips. That's only when there's an inequality sign. Anytime you multiply or divide by a negative number in an inequality, the sign flips. Anytime you multiply or divide by a negative number, the inequality sign flips.
So, okay, so like for the first question, you started it off with 14 and then increasing, and then this one was negative. How do I know what order that?
Look at the way this sign's going. So if x is less than or equal to 4, that means x is smaller than 4. Remember, I do my smallest first. Sometimes it helps to see it, think about it on a number line. This would go this way, so that's negative infinity to 4.
I thought that was negative infinity, not a real number. Negative.
If it ever says it's just less than, the only way it'll stop is if you were between, if it was something like this. That says it stops between 2 and 4.
And this is, we're only talking about right now whether it's a negative and a radical.
Whether if you see a radical in an equation, in a formula. Right. Like if I had any equation at all, if it's got a radical in it, you have to take what's under the radical greater than or equal to 0. Solve it. Yeah. Yeah. You multiply or divide by a negative number, the inequality. Talking about the what? Why it's not 4 to infinity? Because the inequality sign changed, because I divided by a negative number. Less than means you start with negative infinity. Greater than means I start with the number. Yes. All right. That's scenario 1. This is painful. I'm not going to lie. Scenario number 2. Yeah. Scenario 3 is the hardest. Scenario 3 is a fraction. There are only 2, but scenario 3 combines both of them. All right. Scenario number 3 is a fraction. What can you never do with a fraction? Divide what? By 0. Dividing by 0 makes me undefined, okay? So here's what I'm going to do. Instead of looking at what x can be, like I did with the radicals, I'm going to look at what x can't be, and I'm going to leave it out. So remember how we leave out just a single value sometimes with the back-to-back parentheses? That's what I'm going to do with these. So here's what I'm going to do. The denominator cannot equal 0. That cannot happen, yes? So if you set it equal to 0, you know what it can't be. So I'm going to say set equal to 0 and leave that out of the domain. This comes into those asymptotes we were talking about. This is why you have asymptotes in those reciprocal functions, okay? Let me show you what I'm talking about. Now, because since we're doing operations on functions, we'll take one function and divide it by another function. So we'll have to leave the bottom equaling 0 out. All right, so let's say I have f of x equals, let's do something easy first, this. I don't see any radicals, so I'm okay there, but I'm asked to find the domain algebraically. I know that on this function I have a fraction, and what can never happen in a fraction? The bottom can't be 0. So if the bottom, bless you, if the bottom can't be 0, I'm going to set it equal to 0 and say, what would cause me to have a 0 in the bottom? Well, if I had negative 3 in the bottom, I'd have a 0. So I know that x cannot be negative 3. But anything else is fair game, yes? So how do I write a domain that leaves out negative 3? How? Give it to me. negative infinity, negative 3, u. Remember, if we leave out a single value, we do it with back-to-back parentheses every time. That's always what we do. And a u. Back-to-back parentheses and a u. That's right, Luke. We don't. So I have left it out. That's left out. If you think about it, that means I can come as close as I can get to negative 3 without actually being negative 3, and same on that side. Yep, that's because this one has an asymptote at negative 3. It's been shifted left 3. Well, this is no longer my parent reciprocal function, right? This is not my parent reciprocal function because there's an x in top too. So, do I know where the asymptote is right off? Nope. I don't, yeah. This is still one function. This is a rational function. So what I want to do, I'm looking for my scenarios. I'm always just looking for these scenarios. Scenario number 1, radical. Do I have one? No. Scenario number 2, fraction. Do I have one? Yes. Is there a variable in bottom of the fraction? Yes. That's going to cause me some issues. So I'm going to say, okay, what would I plug into x to make the bottom 0? What's going to make it bad? Well, add 1 and divide by 5. So this says x can be anything as long as it's not 1 over 5. So I don't have to worry about top. Top can be 0, right? Top can be positive, negative, 0, doesn't matter. The bottom's the only thing that's going to lead me to some problems. So if x can't be 1/5, how do I write that in interval notation? That's right. Yep. Doesn't matter. Can you do 0 divided by something? You can do 0 divided by 5, that's 5. I mean, that's 0. But if you do 5 divided by 0, what happens? I'm undefined. I can have a 0 in the top, I just can't have it in the bottom. That makes sense. So, like, all right. Thank you, Thomas. Thank you. I appreciate that. He has not quit talking. Holy cow. He is. Look, he's still talking. Y'all ever read that book, The Very Hungry Caterpillar, and he just kept eating? That's right, but he just keeps talking. Unless there's a radical in the top. You wanted to teach, Red?
Yeah, that makes sense. You
know how to do this? The third one is fractions and radicals. All right, when I combine them, same rules still apply. It's just a little bit harder when you got both, okay? This still has to stay positive. This still cannot have a denominator of 0, okay? So let's do a couple combine, and then we'll be ready to combine our domains over here on what we're doing today. Harris is so excited. He is just about to explode. He's so excited. Denominator can't equal 0. I feel like, huh? I feel like Harris doesn't have much love for me or my class anymore.
No, he just told me yesterday. I was going to be at the I love it.
Aw, thanks, Harris.
Upset when we left yesterday, she started pepper spraying.
I heard about that.
That's how upset she was.
I heard.
What is it? How bad is
Teachers talk. Huh?
it? What's she flavor?
Who?
We just had.
Let's say f of x equals. See if you can find the domain of this combined function. But this is a combined function. Try Mark Go. But I know Clara and Ella. Ella Roberts or Ella Derrick?
Oh, I was very cook.
No, this Ella and
Wait, is it because Clara was the Clara had tears?
I don't know.
I hope they don't get their hands on it.
Yeah.
Are you scared?
All right. Okay. I've got two different scenarios going on here. So let's look at both of them and then we're going to do a combined domain. Remember, the rule is if it's left out of one, it has to be left out of both. Okay, that's what you have to remember. That's what makes this one kind of hard. So let's tackle both parts of this. Okay, first of all, let's do the radicals. Okay, so x minus 5 I know has got to stay greater than or equal to 0, which means x has got to be bigger than 0. I a lot of times will put this on a number line because it helps me see it and put it together, especially if I'm combining stuff and I can't think of, wait, is it left out? Is it not left out? So right now, remember, I start with everything and then I start leaving stuff out. So start with everything. Oops, that's not a 0 right there. That's a 5. And so if I'm at 5, I've got to be greater than or equal to 5. So right now, that's where I am not taking the fraction. And now I'm going to look at the bottom of the fraction. Okay, well, x minus 8 can't be 0. So x can't be 8. Where is 8? Here's 8. I got to leave it out. So, yes, my domain is going to be from 5 to 8, u 8 to infinity. Now, a couple of things about this one. If this had been a plus 8, right? So if I had square root of x minus 5 over x plus 8, changes a little bit because this means x can't be negative 8, but look, negative 8's over here. I already left it out, so I ignore it because it's not, remember, if it's left out of one, it's left out of both of them. It's already been left out of the first one, so I don't have to leave it out again. It's just 5 to infinity in that case. Okay?
Wait, how would you write that?
So this one would be 5 to infinity. Because in this case, I was already here, negative 8's over here. That's not in that interval anyway. It's already been left out. I don't have to leave it out. Well, it doesn't matter which one you do first.
But technically,
They gave me a free cone of ice.
Oh, no.
What if I had square root of x minus 5 over x plus 8? And I said, okay, I'm going to do the bottom first. X can't be negative 8. And I come over here and I leave negative 8 out. And then I go, okay, x has got to be greater than or equal to 5. This one kind of trumps that other one because if this is 5 and I have to leave it out, well, if I have to leave it out for this one, then none of these apply anyway, and it's a moot point. It doesn't matter. Yes. I think you said that right. Yes. 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 The wrong domain is wrong. Okay, listen, there's another, let me show you this and then I'll be done and then we'll talk about today's stuff. Find the domain. Find the domain.
Wait, is the divide or multiply by number or plus or minus? Or anything?
You're close.
Can a radical be in?
Yes. All right, I got both scenarios here, right? Radical and fraction. Radical says that x plus 1 has got to be greater than or equal to 0, but fraction says this can't be 0. So all you have to do, whoever said it, yes, I don't know who said it. So since the denominator is a radical in and of itself, if that's all you have in the bottom, I just say, okay, x plus 1 has got to be greater than 0 instead of greater than or equal to 0. What? I don't know. I was listening for that, I guess. Yeah, it's because it can't be 0 because it's in the bottom, right? Right. Right.
Well, what if it was like x
X plus 2 in the bottom under a radical. So 5 over the square root of x plus 2. It's still, so x plus 2 would need to be bigger than 0. It can't be equal to 0. Why can't it be equal to 0? Because the denominator can't equal 0. It won't have to be. It's always, you're always setting it greater than 0 because you're wanting you need your radical to be positive. So the domain on this one, right, whenever I solve this, I'm not using this one, I'm using this. X is greater than 0, greater than -1. It's a parenthesis instead, so it's -1 to infinity. It just changes from a bracket to a parenthesis. Right. It flips.
Why is it not? So the 5 doesn't matter. Why is it not listed as
Yeah. Say it again.
Wait, which one is it when it flips that way?
Less than, so it's -infinity to whatever.
Why is there no like equal?
Less than goes this way. It is greater than 0. X plus 1 has got to be greater than 0, not x. Everything under the radical's got to be greater than 0.
That's why whenever it's a fraction, it has to be.
Square root of x plus 1. Harris, we're going to have to call your mom on that phone right here in front of everybody.
Oh, my pencil.
And tell her you got a problem with a finger. Square root of x plus 1 looks like that. Look at, all right, look. Look, I gotta show you an operation that you don't know, and then we're gonna look at putting everything together. This has been painful. All right, 1028. Okay, I'm gonna rewrite it though. Actually, I need to show you in function operations. I told you that we had, so we're back to the old one, right? We had the addition, subtraction, multiplication, and division. We also have composition, and we did do this in Algebra 2, so I'm just going to, yes, I'm just going to go over this quickly, and then we're going to pull it all together. Composition is when we plug one function into the other. Okay, this is the one where it looks like this, or like this. You could write it that way. All right, what is this? This is whenever we take two functions. Let's say f of x equals x plus 7, and let's say g of x equals x squared minus 4. If I asked you to find f of g of x, right, that means I take what's inside, right, whatever's inside, and I plug that into the outside function. You could, but you don't have to do that here. All right, guys, I need y'all to stay with me, okay? Yeah, tell me where I lost you. So this is an example. This is, I gave you a random f and g. And now I'm saying find f of g of x. So this, remember, whatever is in parentheses whenever you evaluate a function, if I had f of 2, that means replace every x in f with 2, right? So it'd be 2 plus 7, right? If I said, what is f of k? I put a k in there. Same equation, but I replaced the x with k. If I said, what is f of 3x? Well, everywhere there was an x, I replace it with 3x. Whatever is in parentheses is what's going in for my x. This time, though, I'm plugging a whole function in every time there's an x. So what is g? G is x squared minus 4. So this is going to be f of x squared minus 4, which is x squared minus 4 plus 7. Do y'all remember composition now? And so I can do f of g of x. I can do g of f of x. I can even do f of x. It doesn't matter, right? I can plug one function into the other. We're not setting equal to anything. We're just simplifying. We're just plugging in and simplifying. Okay? That's all composition is. Now, what we're doing today is we're doing all these operations, but we're finding that combined domain of those operations. Okay? So, let me show you. Now we get to the good stuff. This is my combined domain. Let's define f of x to be the square root of x plus 5. And let's say that g of x is x squared. Yeah, because I was showing you an easier example. All right, here's what I want you to do. I want you to do the following operations, and I want you to find their combined domains. Okay? We're going to work through a couple together and then by yourself. So before you find combined domains, let's find individual domains first. Okay? Because to have a combined, you have to have individual, right? So if I asked you what's the domain of this one, what would you tell me? How do you know? It's a radical. X plus 5 has got to be bigger than or equal to 0. So x is bigger than or equal to negative 5. If you're a grapher, you split it to the left 5. So it's 5 to infinity, yes? Negative. Sorry. There's no fraction. There's no radical. The domain is just negative infinity. Okay. Because it's 4 equal to. Yes. Find the combined function along with its combined domain. F plus G. And maybe I write it like this. Can you combine them? Can you do, let's write them in here. F is square root of x plus 5. What's G? Do I have any like terms? I leave it. I stop. It's static. That's it. That's it. That's it. That's not the hard part of this. The hard part is the combined domains. What is the domain of my new function? So I have to put the two domains together and then look at this as a whole. Okay? So together, these two domains, this leaves out everything smaller than negative 5. This one doesn't leave anything out. So and this one doesn't have anything new in it. There's no new radicals or new fractions. So what's my combined domain? No. It's just negative 5 to infinity.
If it's left out or one, it's left out.
Wait.
I'm not putting them into each other. I'm just adding.
Hold on. What's left out? Everything smaller than negative 5.
But we still left out everything
No.
But if it's left out, if we said
I left out everything before negative 5. Right. X squared leaves nothing out.
But if it's left out of 1, then it's left out of 1.
Right.
So they're like,
So because on this one, I'm at negative 5 and I do this, so I left all of this out of this one, I have to leave that out of anything I do from now on. If I use that function, I have to leave that out, no matter what. That's okay, you can. All right, do this one. Find the new function and find its combined domain. You could.
are we just using the same problem?
Guys, I know I've been talking a long time, but y'all stay with me a little bit longer. Same F and G. Same F and G.
Well, I asked my mom and I made sure to forget. I'm still trying to find it.
Sorry.
It would be the same.
All right.
Oh, wait, no.
So look, as I combine these domains, right? I know this is my combined domain when nothing else happens, but I have a scenario that has unfolded. In the process of doing all this, so I had from negative 5 to infinity. But in the process of doing all that, I've got a fraction all of a sudden. What can't happen with a fraction? X squared cannot be 0, which means x can't be 0. Is 0 in my defined domain? Yeah, so guess what? I gotta leave it out. I gotta leave it out. Yep. So now what is my domain? What is my combined domain of this function? Negative 5 to 0. and 0 to infinity.
Because you gotta leave out the zero because the bottom can't be zero.
That's right. Luke's got this. It's a fraction. Anytime I have a fraction, I set the bottom to 0 and I say that's what it can't be.
I don't care. I know. So the point is, if we, I don't understand, because the last time we did the fraction, we ended up with 8, right? But when it was like X minus 8.
I guess
So how did this one, I'm confused on still how we got 0 on the bottom. I understand we did not include 0.
It can't, and it's already included in that. 0 happens over here. It's in the numbers that I said I could use, but I can't use that one, so I have to leave it out. All right, guys. Yes, yes. All right, look, guys, I need y'all with, this is not easy, okay? It's not, but it does not make it easier whenever y'all start getting squirrely like that. It makes it harder. Okay. Find the new function and find its new combined domain. I have really tried to keep y'all with the partners that you chose, but it does not seem to be working for y'all.
You see how well I'm understood?
All right. I'm finding f of g of x. F of g of x. So that means my g is going into my f, and I am simplifying. It'll define f and g each time. So it'll tell you, it should tell you on there what f and g is before you start.
Would that not be fun? It's like that.
It's not distributed, it just replaces the x. So what was f of x? Guys, the f of x is the square root of x plus 5, so I take whatever g equals and it replaces just that. It doesn't multiply or anything like that, it just replaces it. So when it replaces it, I get the square root of x squared plus 5.
I thought we were like.
All right, now my combined domain, who's got, there's more over here, they didn't make it over there. No, it's the same. They're the same. I just sent half one way and half the other, but I didn't divide it well. All right, so my combined, remember I'm already at -5 this way, yes? Does this create any new restrictions for me? X squared plus 5 has got to be greater than or equal to 0. So x squared has got to be greater than or equal to -5. Now wait, think about this logically. If you square a number, what happens? It's going to be positive. This is always going to be bigger than -5. This is always satisfied. There's nothing new to leave out. So my combined domain is still -5 to infinity. Okay? Okay. All right, listen. I think, guys, okay. I've got my original combined domain, which is from -5 to infinity. Yes? Everybody sees that. Everybody can understand where that comes from. Yes? Now I take my new radical and I set what's under here greater than or equal to 0. Okay? When I solve that, I got x squared is greater than or equal to -5. X squared is always going to be bigger than a negative number because you're always going to get a positive when you square anything, right? In other words, if I solve this, I get x has got to be greater than or equal to some imaginary number. I'm not worried about imaginary numbers. It's not impacting my domain. So I stick with that original domain. Okay? Now, this is going to change if I switch this around to do g of f of x. What do you get now? Now what happens? This time I'm plugging in the square root of x plus 5 into g.
I think that's the part that's
It's squared, so the squared is outside, so it's what?
How did we start with
no. I think
none of this really doesn't make sense.
It's very
How
confusing.
did you scratch up? Why did you scratch up?
Y'all, I remember it being confusing when y'all did it in algebra 2. Y'all were confused.
like as soon as I'm good, as soon as you start doing that, and I'm just like, where did you like
Go inside out, always inside out. Take your furthest inside and plug it to the outside. All right, shh. Guys, I'm getting frustrated, and I know some of you are too. And it's because it is hard. If you understand, work on the homework sheet. That's why I gave it to you. So nobody else should be talking. You should be working through the homework silently if I'm boring you and you understand. If not, you should be locked into me completely with this homework. Okay? So those are the two options right now. We're either dug into the sheet or we're locked into this because we don't understand. All right. All of them. All right. We obviously need practice with this. You should have just gotten one. Oh, you shouldn't have gotten that one. Yeah. Just the one that says homework.
Can you give us a longer video?
All right. When I square this one, I just get x plus 5. Okay? Does x plus 5 on its own create any restrictions? No, it's linear. It's negative infinity to infinity. So the only thing I have to think about is what restrictions did I start with? Negative 5 to infinity. See how these keep coming back? Negative 5 to infinity. That'd be greater than or equal to, though, because it's not a fraction. Because I used a function that left something out, it has to be left out of the combined one. That's why. Which one, the green one? I take what's inside and I plug it into this function. G is x squared. You're not multiplying it. You are literally, if you could come into this one and you could take your hand and physically take it out and then put x squared in its place. You're not multiplying it, you're replacing it. I literally, when I used to teach this in CP Algebra 2, I would come up to the board and I'd have sticky notes for every single thing. When I taught it in Algebra 1 last semester, I had them stand up here with papers. One person would have an x, one person would have a plus, one would have a 5, somebody had x squared, and I'd say, okay, x, go sit down. X squared, stand in their place. You literally take it out and put something in its place. Okay? All right. Right. Which is never going to happen. It's never going to happen, so I ignore it. All right. Yeah. That's always following that. Every single problem you do with the f is going to leave out anything smaller than -5. Even if the radical goes away in the end, like it does over here in this last example, see how it went away? There's no radical left in here. X plus 5 is negative infinity to infinity. But because I used the function that left it out, I have to include what was left out to start with. So if you ever leave it out at any point in time, you have to leave it out in the end. So that's why it keeps following everything, because I keep using that function.